Hi, in this video, we are going to talk about the so-called encounter problem. And the encounter problem, the typical setting is you have two people, like in this example, two people, they walk or ride a bicycle or drive towards each other. And the question will be, how long does it take for them to meet? This is one of the very basic versions. So it's a distance and speed type of problem. And so we need to know the basic relationship, which is the distance equals speed multiplied by time. Okay. And for some problems, that's all you need to know. Distance equals speed times time. But as you will see in this video, there are many examples where the situation can get quite complicated and the problems actually gets quite tricky. So we'll do some examples. Hopefully you can learn from these examples and can handle these tricky problems. But let's first start with a basic example. This is kind of basic example. You have two people. We know they are 3,000 feet apart and they walk towards each other. And we are given a speed. One works at 80 feet per minute. The other works at 70 feet per minute. And we're just looking for how long does it take for them to meet. Okay. So when you solve a problem like that, and basically when you solve any encounter problem, it's a good idea to just draw a little graph to remind yourself what's going on. So you have A and B. They are 3,000 apart. And they work towards each other. Okay, so in this case, we know what the distance is. Distance is 3,000. And in fact, the speed is also given to us. What happens, we know that A works at 80 feet per second and per minute. B is 70. So which means every minute they are 70 plus 80, which is 150 feet closer. Okay, so what is this 150? This is indeed the speed. This is the speed. Because you need to combine A and B here. So for this problem, all we need to do is look at the formula. Distance equals speed times time, and we're looking for the time for them to meet. So time is just distance divided by speed. Distance is known, speed is known, and we do the division, and this will give us the answer, which is 20 minutes. Okay. All right. So this is one of the basic versions of encounter problem. But even for this problem, one can make a little twist and make it slightly harder. So let's do a follow-up problem. Let's say, because A works faster, A works 80 feet per minute, and B works 70. So when they meet, it's clear that the meeting place will be closer to B than to A, which means A would have walked a little bit longer. Let's say A feels it's a little unfair. So say if they agree to meet at midpoint. So B is slower, so how to accomplish that? Well, clearly B just need to have an early start. They cannot leave at the same time. So So B needs to have a head start. B needs to start a little early. How much earlier? Let's see. This is the question. Okay, so you can pause to think over this problem. Now, how do we solve it? Well, again, we draw the graph. Now, what happens is they want to meet at midpoint. So what does that mean? Well, it's 3,000 feet between A and B. So midpoint will be 1,500 and 1,500, which means A will need to work 1,500, B will need to work 1,500. And because they have different speed, the time that needed for A and B is different. Time for A will be 1,500 divided by 80. And time for B will be 1,500 divided by 70. Notice that the denominator for B is smaller, which means the fraction is bigger, so it takes longer for B. So it's clear how much more time we need to spend. Just take the difference. We know the time, so take the difference. And this will be the amount of time that we need to get a head start. And the numbers here are not so simple, so, well, I'll just do the subtraction, but use some common denominators, 56, and I think this is just 150. And simplify, 75 over 28, roughly somewhere between 2 and 3 minutes. That's how much time B needs to get a head start. Okay, now next we're going to look at some more examples where the situation is not as straightforward. In this example, we have, again, A and B lives 80 miles apart, and I will just draw the graph, see what happens. So this is A and B. They're 80 miles apart. And they start to ride bicycles towards each other. And 2 hours later, they meet. Okay? They meet at a certain point. And then after they meet, what happens is A somehow just turns back. And B continues. And when A reaches home, B is still at the point 4 miles away. Okay, so that's what the question is. And they ask you, what is A's speed? Okay, so I roughly draw the picture. Now let's see how we solve this problem. And we'll want to say, okay, I want to figure out the distance divided by time. So in this problem, it's unclear what is the distance that A has traveled, because all we know is he traveled to somewhere, but not necessarily halfway point. We don't know it's halfway somewhere, and then turns back. So we don't know the distance. Okay, so what do we know is we do know the distance that B traveled. So because the distance B traveled, you see, B traveled all the way until 4 miles away from A. So we know the distance B traveled is 80 minus 4 equals 76. So this may suggest that we do something with the speed of b instead. Okay, so let's see. What is the speed of b? Well, we need to know how much time b traveled. And what do we know? Well, we know that they meet 2 hours at a certain point, but then A turns back. So do we know how long did B travel? Well, in fact, we do, because when A turns back to get back home, so A goes here, it takes 2 hours, and when he goes back, of course, it also takes 2 hours because same distance. So here, actually, you know the amount of time they travel. Time is 4 hours for A. And the same for B because they travel the same amount of time. Okay, so what does that mean? That means B's speed is 76/4, which is 19. Okay, 19 miles per hour. But how does that help for calculating A speed? But now we're in a situation we can calculate because we know that A and B, they meet after 2 hours. So we know the combined speed because for 2 hours combined they cover 80 miles. So the combined speed is 80 divided by 2 equals 40. Now A speed is just the difference. So you see in this problem, it's not so easy to find A speed. And you're not given A's distance, but you can figure out B's distance. And you're not given B's time, but you can somehow figure it out from the problem because A goes forward and goes back. It's basically taking the same amount of time to go back, so therefore the time B traveled is 4 hours. And from there, you can start to solve the problem. All right. One more example. Now, in this case, again, let me draw the picture to show you what the problem is. So you have 2 cars now, and leaving from the same spot, X. And there's A and B 2 cars going from the same spot, and they both go towards Y. And A, the speed is given, 42, and so is the speed of B. And A is a little quicker, so when A reaches Y, it actually has time to turn back, and then it encounters B at a point. And what we know is this point is 20 miles away from Y. And they ask you the distance between X and Y. So in this problem, we are given a speed. Basically, to find the distance, remember distance is related to speed, is speed multiplied by time. We just need to figure out the time. Okay, now how do we figure out time? Well, to figure out time, you need to know the distance speed. So it goes back to figure out the distance. And in this problem, there's only one distance that's given, which is this distance. 20 from the place they meet, let's call it Z, and Y. So we need to make good use of this distance 20. And what does 20 mean? Well, look at the picture. A covered this much, and B covered that much. So you see B covered a little bit less, and how much less? Well, A covered this part ZY and the part going back, so double the part ZY. So if you look at 2 times 20, which is 40. This is how much more the amount A traveled more than B. So 40 is actually the difference between the distance traveled between A and B. Alright, so now we can do the time. Time need to be the distance divided by the speed. So here, because 40 is the difference between A and B, the speed we have is the speed difference. And A is quicker. And every hour, A travels 4 miles more, 42 minus 38, 4. And in order to travel 40 miles more, you need 40 divided by 4 equals 10 hours. So indeed, A traveled 10 hours before he meets B. So time is 10 hours. Now once you know the time, again we can do the distance equals speed multiplied by time. So in this case, we know how many miles A traveled because A's speed is 42. So this 10 times 42, 420, is the distance A traveled. But of course, this is not the answer because the answer with the question looks for the distance between x and y. And what A did is he covered the whole xy and then plus 20 more miles. So xy is 20 less than 420. So the answer is 400 miles. That's the distance between x and y. Alright, this concludes the video on these encounter problems. And we'll have another video which are going to deal with even more advanced problems. And encounter problems indeed can be very tricky.